Yeah.
Yo, player, the sky's the limit. Throw a rack and get up in it. Quit playing and make some digits. Let me tell you about some limits.
About to talk about continuity. This is a great opportunity for you to learn more about limit and calculus. In order to define the continuity at x equals c, you don't need to be in BC because you have me to teach and I have the answer key. Yeah, I am just going to spit verses that comes to my mind. Number 1, f of c has to be defined. Then check off one of the 3 definitions of continuity. I'm too Kichan not to rap about number 2 and 3. But since I'm the teacher in this case, I'll finish my lesson real quick. The limit of a function has to approach a point and the graph will look like connected joint. Just like how the limit from the left and the limit from the right approaches the same point. Values have to be existing and equal to f of c. If func f is not continuous, as c it is discontinuous, period. I'm done with this for high school. Now I'm off to chill and kick back with my homies. Luke and Botond, please say no more to Calc B because Team Lee's about to take over, baby.
Yo, player, the sky's the limit. Throw a rack and get up in it. Quit playing and make some digits. Let me tell you about some limits. The first things we learn in calculus AB are limits, the tool we use to perceive the infinite. You might not be too enthusiastic, but L'Hopital's rule is really fantastic. We use derivatives to figure out limits in indeterminate form, so listen to this. 0 over 0, infinity over infinity. Oh, never stop. Derive till the value becomes definite. Oh yeah, definite. But watch out, L'Hopital's might get tricky. Don't use the rule in the following cases: when the limits of the two parts are not 0 or infinite, when applying the rule gives an expression that oscillates, or when there's a better way to solve the problem. Simple. You get it? See it? Try it. Derive the numerator and then the denominator. You don't need a calculator. Just be your own operator. Oh, Bernoulli, may I call you Bernoulli? Your name is a beauty, your theorems are holy. We know you introduced the rule to your homie and the rule is now called Lopi. But don't worry, we all know history, so I hope there is no anger. L'Hopital's rule is no danger.
Yeah.
Yo, player, the sky's the limit. Throw a rack and get up in it. Quit playing and make some digits. Let me tell you about some limits.
To talk about limits, you gotta see what we mean by infinity. You see, infinity goes as far as the eye can see. Indefinitely, forever and all eternity. And when we talk about limits, you should know infinitely close is where the function goes. It doesn't touch it though, right up to point A, then it dips, yo. Now we about to talk about what happens when we use a special calculus contraption. Improper integrals, proper integrals, check it. You may hate it, but don't disrespect it. You see, math itself has a set of rules to prevent y'all from acting a fool. Infinity not on your number line like 1879. When we take the integral from 1 to 2, we proceed just like we normally do. Integrate the function by various methods. On this subject you've been quizzed and tested. Area under the curve from point to point. Calc AB up in this joint, except this time what you gotta do, replace what you integrate to with any old variable, could be A or B or L, then you take the limit as that letter approaches the infinite, integrate just like you normally would, use the variable like you probably should, then when you're through and done, evaluate your function. Plug back in infinity, and the rest is history.
Yeah.
Yo, player, the sky's the limit. Throw a rack and get up in it. Quit playing and make some digits. Let me tell you about some limits. Yo, player, the sky's the limit. Throw a rack and get up in it. Quit playing and make some digits. Let me tell you about some limits.
Yeah,